Example 8.9. Let's compare projects in example 8.8 using equivalent annual annuity method. What is the net cost benefit of cash flows from examples 8.1 and 8.5 that we used in example 8.8 at 3.5%? Based on this, which project would be recommended? We find that the two projects have unequal lives, hence NPV does not provide a clear picture. So we can see that this project has only 1 year and this project has 3 years. So it does not really provide a clear picture. So therefore, we use the method of equivalent annual annuity corresponding to the period to which the project is carried out in table 8.4 below. Now, the important part is, again, let's do a recap. In example 8.1, so this is cash flows from example 8.1. This is example 8.5, and this is modified example 8.5, so example 8.8. Initial cash outflow is $2 million for all of them. It is a single cash inflow for example 8.1 of $2.7 million, $1.5 million in net revenue, and $1.2 obtained upon resale of the aircraft. In example 8.5, we have the 2 million, 1.5, 1.5, 1.5 million, and the terminal cash flow upon the resale of the aircraft is 1.2 million. In example 8.8, we modified 8.5 to decrease the intermediate cash flows. Something like the sales manager comes and says, hey, we're not going to make those kind of sales anymore of $1.5 million. We're only going to make $650,000 sales. So we modified the cash flows and found a lower net present value, but it was still higher than the 1 year project. But this might give us a biased view, because the 1 year project really is giving us $600,000 in a shorter span of time, whereas a $900,000 so obtained is over a longer duration. So the concept of equivalent annual annuity in this case is, what is the equivalent annual cash flow that will make us indifferent between receiving the $608,000 from the 1 year cash flow versus the $903,395 over the 3 years. So the function we use in Excel is the payment function, PMT, and so it's those equal payments over the period of the project. PMT 0.035, the rate. The number of periods, we can just use the count function. So count the number of entries here, and then just return the value of the number of periods so used, minus of the net present value, and the future value is 0, because if you want to convert the net present value into equal cash inflows over the life of the project, then the future value would be 0, nothing left behind, and the type would be end of the period consideration. So Alt OE, let's make this to 0 decimal places, and let's not use a symbol, none. All right, so the equivalent annual annuity of this single NPV project, let's see, payment count, just going to make sure that we did the right thing. So equals PMT 0.035, number of periods is 1, the present value is minus of x7, and the future value is 0, and type is 0. Again the same thing, actually Control C, Alt EST. Okay, so the equivalent annual annuity is $630,000 at 3.5%. Next, now we do the same thing for the higher cash inflow project. We had the 1.17. So even though we're doing this project for a higher point of time, the equivalent cash that we receive every year is higher in case of example 8.5. But when we modify it so that the annual net revenue decreases, the equivalent payments that we get per year are only $322,000 per year. 453, of course, that's a change. But the point is that now this is not as good as this anymore. In other words, what equivalent annual annuity method or the is telling us that the equivalent cash that we would get per year from this particular cash flow stream is only $322,453 per year, whereas this is $630,000 per year. So which is better? Well, if we are looking at the annual equivalent consideration, then cash flows from project A in example 8.1 are far superior. And that's the beauty of the equivalent annual annuity method. Generally speaking, equivalent payments go up as the present value goes up. However, if the time periods are different, then there might be changes. And that is the importance of this example 8.9. So which one do we choose based on the equivalent payment method? Well, we'll choose the 1-year project because its equivalent annual payments are higher. And that's example 8.9. Thank you for listening.